Hey, how come it's not there? Okay. Okay, everyone. I need to say today is not such a beautiful day. I want to remind you all again that your exams are coming soon, boys and girls. I'm really a bit sad that no one did the homework. Not one single girl did the homework. Hey, I want to remind you guys again. Yeah, I don't want to be like the bearer of bad news, right? I don't want to be the guy that tells you so. I'm definitely not your mom or your dad, right? But I want to let you know that this physics, oh, okay, very good. For physics, right, it is very much like mathematics. It's really simple to see me write and do all the questions and explain, and then you say, oh, it makes a lot of sense. It's really easy for that to happen. But doing it yourself is like a totally different story. And I can almost guarantee you, if you still don't do it now, right, which is July. Okay, let's assume that last week there was a lot of events. Okay, let's go past that already. But I want to assume that if, let's say now you don't start, which is like the second week of July, you have July, August, September, 3 more months only. If these 3 more months, unless you are like already scoring 70 and above, you can slow down the brakes here. But to my understanding, I think there is only a few above 70s here. The rest are like below the average threshold. And now is definitely the time to start panicking already. If you don't panic now, you're going to give up later. Because this is what usually they'll say. They say, okay, I'm going to do it next month. Then the next month comes, they say, I'll do it next month. And then the next month really comes and it's like, shit, I only have 1 more month to do the work. And then it's like, forget it, I'll just pass. Which is definitely, hey, I want to ask you one thing. Do you do the questions?
What?
The paper from last week?
Okay,
Never mind.
last week?
Never mind. Never mind. I was hoping and praying at least you did it, but now I know. Now I know. Okay. But anyways, yeah, like I just mentioned, please start doing your question papers right now. I know some of them are doing it, like Shani and who's called Abigail is doing it. And I know because they'll ask me, hey, how to do this question, right? It's very, very important that you guys actually start doing it, right? But anyways, moving on to the light chapter here. Let's go for a really quick revision for all the things you need to know, and then let's attempt some of the questions right away already, guys. Okay. First things first is for the light chapter. I will only go through 2 things, guys. It will either go through reflection only, or it will go through refraction. Okay. Now for reflection of wave, if let's say they ask you this question in IGCSEs, if they ask about reflection, most of the time they'll ask you to locate the image or locate the object or place where your eye level is. In most common questions, they'll give you a mirror like this, right? They'll say that this is a mirror here, right? And then they'll say that, okay, right now I have an object that is somewhere around here, okay? This is my object. And then I have my eye somewhere located here, okay? Then they'll ask you to draw 2 light ray diagrams to indicate where the image will be. Now, there's always a trick to this question, guys. There is an easy hack to this question is, what you do is you take your ruler, right, and you measure how long this distance is. You measure exactly how long this distance is and you place this here. This will be your eye for sure, right? But of course, in your IGCSEs, they don't only want just this, they want you to draw the light rays to locate the image, guys. So if they ask you to draw the light rays and 2 light rays are the normal ones, if it's just 1 light ray, which they'll almost never ask, it will just look something like this, right? It will just look something like this, and this is where your image will be, They'll almost never ask this in your IGCSEs unless you're extremely lucky this year, which I highly doubt, right? So most likely it's going to be 2 light rays. And if they ask you to draw 2 light rays, guys, 2 light rays will look something like this. You're supposed to draw 1 light ray first, and you're always expected to draw the normal. Then after that, you beam it down somewhere like this. Then you draw your second light ray that looks something like this, and then you beam it. Oh my God, is it supposed to be here? I think it's going to be somewhere around here. Yeah, you're going to beam it down like this, and this one beams it down like this, right? Why is it important that you have this kind of thing here? Because at the end of the day, you're supposed to draw the virtual light rays that look something like this, guys. Let me use a different color. You're supposed to draw the virtual light rays that look something like this. And wherever they intersect, this is where the image will form. You want to have a mental picture of this, because having a mental picture of this, sometimes when you go into exam, you can actually reverse. You can do the whole thing in reverse and it will still make sense, guys. This is one of the most common IGCSE question in terms of reflection of light, guys. Which I'm sure you guys have definitely seen something like this before, right? Not very. It's a mirror. Yeah, and this one will be the second light ray as well, the second normal, guys. The concept here is still the same, guys. The incident angle, the reflected angle, the incident angle, the reflected angle, all these should have the same angles, and thus is supposed to kind of go triangle mode towards the top one, guys. It'll be triangle mode towards the top here. This is very important, guys. They ask this a lot of times. Okay. Okay. Yeah. Then this is reflection, which is actually the relatively easier one. The refraction one will usually leave students a bit confused, guys. They will give you they will usually construct a question somewhere along the line like this. They'll say that, okay, this is a swimming pool, this is the water, and then there's a fish here, let's say there's a fish here. A very sad clownfish. But yeah, anyways, let's say they say that there will be an eye here, right? And they'll ask you to draw the light rays yet again and locate where the image is. If let's say they ask you to draw one light ray, which yet again I highly doubt, because they almost never ask this. One light ray will look something like this. It will go to the surface here. Then after that, the speed of light slope down, right? So it will actually bend closer towards the normal, and this is where the light rays are supposed to be, right? And your image will be somewhere around here, right? Your fish will be somewhere around here, the exact same spot, right? But like I mentioned in class, which I assume everyone has forgotten, this thing here is just a virtual image, guys. It's not really there, and that's why, if you stand on top of the swimming pool, you always see that it's more shallow than it really is. It's because our brain perceive light to travel in a straight line, right? But in reality, when the light travels from one medium to another, in this case here, it will be the air to the water, right? It actually slows down and the speed of light changes. When the speed of light changes, the angle changes as well, guys. So this is actually very, very important. You need to know this. So yet again, of course, like I mentioned, they will not ask you to draw one light ray diagram. They will instead ask you to draw two light ray diagrams. If they ask you to draw two light ray diagrams, you always want to have the idea that the light ray is going to kind of triangulate towards the object, right? So in this case here, if I were to draw the light rays, it will look something like this. It will look like this. And after that, of course, because it enters from one medium to another, right? So what's going to happen is it will go and bend towards the normal. It's going to bend towards the normal again. Oh, maybe this is not so well drawn. Let me redraw this again. Yeah, something like this. Easier. Okay, then bend towards the normal, bend towards the normal. Okay, it's going to look something like this, right? And be careful not to draw parallel lines here, guys. My drawing is a bit shit, but try not to draw parallel lines here, because at the end of the day, you have to remember you're going to extend the light ray, right? If you extend the light ray, if it's parallel lines, you'll never get the image law right. So what you want to do is you want to try to triangulate it as much as possible, right? So that at the end of the day, I gotta redraw the whole thing. It kind of looks something like this. Yeah, it's not more fat on the top and skinnier at the bottom. Yeah, you got the right idea. Looks something like this. Because at the end of the day, guys, you're supposed to extend the light rays to meet somewhere here, right? And then this is where your fish is going to be, guys. It's supposed to have the idea that the light rays are supposed to travel in a straight line, but because it enters a different medium, it bends here, guys. It bends in the different medium. This is also a very, very, very common question in your IGCSEs. If they ask about refraction of light, they'll most likely ask you to draw this. So you should have a mental image of this in your mind. So yet again, you can work backwards. The dotted lines are the virtual light. The solid lines are the real light. Okay, dotted, virtual, solid, real. Dotted, virtual, solid, real. Very important. This one, it always comes out like you'll be asked to draw a lot of times. Okay. Okay. So, oh yeah, of course, there's a lot more things that you need to know in this chapter here. After this, if you understand this thing here, the next thing is going to be the 3 formulas. Guys, what's the 3 formulas for refractive index again? Sine what? Sine I over sine R. Good. This is the first one. The second one, 1 over what? Sine C. Very good. It is. And the final one? N equals to refractive index. It is the refractive index for those who do not know. What's the third one hour? The one that requires the speed of light 1 hour. Oh my Jesus Lord. Okay. Refractive index is like how dense it is compared to air. Air will have a refractive index of 1. Water will be heavier, so it will have higher refractive index. Glass will be even heavier, so it will have even higher refractive index.
The lower it is, the more straight.
The lower it is, yeah, the more it's not going to bend now. Right, but usually no one. Yeah, so like let's say for example, if I have refractive index of 1, right? If let's say I have material refractive index of 1, then the light rays will just travel straight along because air is refractive index of 1 ma. But if I have refractive index of 2 here in this thing, it's going to bend a little bit more, right? It's going to bend like a little bit like this, right? And if of course I have refractive index of 3, it's going to bend much more. It's going to bend like something like this. The higher the refractive index, the more the speed of light bends up. Okay, but they'll never ask you this because yet again, it's too simple. Right? The third formula, guys, it's C over V. Do you guys remember what's C and what's V or not? Guys, I always tell you guys this, right? You know, like the famous Einstein equation, E equals to mc squared. Has anyone seen this formula before? Right, what's the C in Einstein's C? It is the speed of light. Very good. This C is the exact same C as this, and because this is speed of light, this will be 3 times 10 to the power of 8 meters per second, and this will be the speed of light in the medium. The medium could be anything. It could be the glass, it could be the water, it could be the plastic, or whatever, right? But it's going to be the speed of light in the medium. Oh, sorry, that's a question again. C over. Oh, Shani was the one. I wish you were here, Shani.
For the second one is sine C.
Sine C is the critical angle. This C is the critical angle, guys. For those who do not know, this is critical angle.
Is it the one where what the half circle and then
yes.
closer internal reflection?
Yes. Good. Since we're on this topic, which some of you guys have no idea, laugh nervously. Oh my god. Hey, everyone done copy. You'll need this for the calculation later on, my guys. Everyone done with this, All right. Then for those who do not remember what critical angle is, guys, critical angle, all right, is equals to the maximum angle of refraction that occurs. Okay, it's usually defined as the maximum angle of refraction. Right? What the hell? Refraction. Okay, what do I mean by that? Let's go for a simple explanation. Let's say today I have a glass block that looks something like this, the half circular glass block. Okay, everyone don't copy first, guys. Please pay attention. The copy can come later. Guys, if today I have light ray entering here, at 90 degrees, that's why it doesn't bend, guys. If light ray enters a different medium at 90 degrees, it will not bend. Then obviously at this angle here, there is an angle, right? Usually if light travels from more dense to less dense, will it bend towards or away from the normal?
More dense to less dense.
More dense to less dense, will the light bend towards or away from the normal? Away, very good. So if let's say this is the normal trajectory, this will be bending away, right? Today, if let's say this angle here is 40 degrees, right? I increase the angle more. If let's say I increase the angle more, can I say that obviously because the angle here is greater, the incident angle is greater, the refracted angle will be greater as well, right? It's going to look something like this, but it will come to a specific point known as the critical angle where maximum refraction occurs. Okay, so let's say here, the critical angle is like, let's just say 50 degrees, right? Maximum angle of refraction means to say here, means to say it's going to be like here to here, right? One straight line out. Yeah, something like this, right? Where it is 90 degrees here already. This is what we call the critical angle where maximum refraction occurs. Okay, maximum refraction occurs at the critical angle. If we increase the angle even more beyond the critical angle, what's going to happen? Good. Total internal reflection will occur when you increase it beyond the critical angle. So this is total internal reflection. This is critical angle, and this is just normal refraction.
Total internal reflection will have like the same angle.
Yeah, it will obey the reflection law already. Incident angle will be equals to a reflected angle. Yeah, look, what do you want? And what the hell? Didn't I just say this? No, C is the speed of light. V, you're talking about this. Oh my God. This, you're talking about this V, right? This V is the speed of light in the medium. Which could be either the glass, the water, or the plastic, or something. Yeah. C is the one in the air.
No need exactly. They want was not really sure. Are you sure? No.
I'm panicking. Okay, guys. What else do you need to know from this chapter here?
Lens.
Lens. Yeah, let's talk about lens. Critical angle. What?
That's the one where you do the concave, convex.
There is only convex, there is no concave.
What's concave?
Concave is the one that is not in syllabus. So it's the circular one, the lens. The circular one. I don't even know it. It's not in the syllabus. Only a convex only. 很明显是刚刚睡醒啊。Okay. Wait, sir, can draw the thing to show like the image reflected into the eye, then the lines from show. Which one? Which one are you talking about, Kenny? The first thing you drew? This one? This one? Okay. Wait, if the object they give is square, then you draw square now. Then how to position the lines? It doesn't matter, you still choose the same starting point and the same ending point only. It's something like this.
What's this thing called? This one.
Reflection of light rays. Why is everyone like never seen this chapter before? Also, both lines start at the same point. Yeah, they both start at the same point, but you want it to reflect at different points. You want it to reflect one here and one here. At the end, you want to make it like a triangular shape that goes upwards here. You know what I mean? Yeah. And then this one also, you want a triangular shape to end here. You know, something like this. No, that will be the simple diagram. This, what you show is a simple one. This is the two light ray one. Yes. Okay, everyone. I'm copying. Let me go to the final thing that you guys need to know, which is the lens one, guys. Now, in your lens, right, there are a few things that you definitely need to know and a few things that you must remember. Number one, there are only mostly two types of lens that they'll ask you. The first scenario will look something like this. They'll have an object here. Then after that, your light rays will be something like this, cut through the focal point, cut through the optical center, and this is where your image will be formed, right? This is the first one. Okay, this will be inclusive of anything but magnifying glass. Everything else will most likely be this in your exam. Okay, if you are asked to draw this, right, there are a few things you need to take notice of. Is the first thing here first is your first light ray is actually going to be parallel with your axis. All right, it's supposed to be parallel with your axis. It's supposed to hit the normal, guys. It's supposed to be parallel, hit the normal. Then after that, it's going to cut through the focal point straight away, guys. Then the second one will cut through the optical center, and wherever this image, wherever the lights meet, this is where the image is formed, guys. This one here will usually be real, will usually be inverted, right? And usually it will be either diminished or same size. Either will be diminished or same size. Smaller. It will be smaller. Okay. These are the common first scenario. Which the second one is more important, which is going to be the magnifying glass. I think out of 10 of the questions that involve lens, at least 6 to 7 of them will ask you about magnifying glass. Magnifying glass will look something like this, guys. They'll give you like, okay, the lens will be here, and then let's say this is your focal point, and this is your focal point, and this is your optical center, right, guys? Hey, pay attention. This is very important, guys. Your object for magnifying glass must be placed in between the focal point and the optical center. Must be placed here. Must. A lot of questions will test you on this. So you need to know that it will be placed in between the focal point and the optical center. Okay. And yeah, this is called the focal point. This is called the optical center. It's the same focal point also, because the light ray can pass through two sides. Light can pass through here, it can pass through. There will be another focal point here also. Oh my god, it's like you've never seen this question before, seriously.
Wait, so go watch the Indian guy on YouTube. The one, yeah, show one.
Shut up, what? The first light ray will definitely intersect at the focal point, yeah. So I'll show you a more detailed version diagram later on, right? So if let's say, right, they give you something like this, you need to know that your object must be placed in between here and here. Must, they'll test you on this, and then if they ask you to draw the light rays, right, you are supposed to do something like this. You'll go straight line, cut through the focal point, right? Then straight line down through the converging lens here. And you'll straight away notice that these two lines are diverging light. If the diverging light means to say the image will never be here. The image, no way in hell it's going to be here. The image will be somewhere here instead. Why? Because up until this point, you're supposed to draw the dotted virtual light, and this is where your image will be, guys. This is your eye will be here. Reflection. Which one? Here? Here? Nothing. Yeah. You're talking about this region here, right? This here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which region?
Wait, but why is the eye underneath?
The eye for sure is underneath one because this is where the light ray is coming in. Let's see shit like this. It'll be like this. Yeah, if you imagine if you're holding the magnifying glass here, right? Then this is where your eye will see the object, the image, right? Have you ever played with a magnifying glass before? Oh my god. See everyone. Hey, for those who have absolutely no idea how this is, it's actually supposed to look something like this, guys. Oh, sure. It's actually supposed to look something like this. It's supposed to look something like this, guys. I mean, this is like the full complete diagram of how it's supposed to work. Usually they'll ask you to draw either this one here, this one, or they'll ask you to draw this one, which are the two most common ones, guys. Yes, it is. That's called a concave lens. The concave lens is not in your syllabus. Has your school been teaching you that?
Right, right.
No. Concave is not in the syllabus.
The one, yeah. The one.
Sorry, what do you say? Yeah, it is. This is in between, right? This is the focal point, is optic. 这个不是magnifying glass 来的，这个是 magnifying glass， 这个不是 magnifying glass 来的。They will usually ask you this one, the magnifying glass one instead. They will ask you the magnifying glass one instead, guys. 没有学过这个东西。I'm not sure because I have already threw all the information away. But the concave one looks something like this lah. It looks the lens will look like weird one, very weird shit going on. This is the.
You don't have to know, right?
No, you don't have to know. The light ray will look something like this and like this and very weird one. That was concave. This one is the convex one. Yeah. Just remember the cave is the one that caves in, right? Convex is the other one that is like the circular one, okay, the oval shaped one. Oh my lord.
So you got sent this the thing you sent to us. What's the answer for the first one? What's the answer?
I don't know. What's the answer? What's the question? Wait, later that one I'll explain. Okay, everyone, these are the things that you need to know, and the characteristics will be, it's definitely going to be virtual, right? It's definitely going to be magnified, and it's definitely going to be upright, guys.
What is virtual?
Virtual is, okay, let me tell you how to, in your exam, that's a good question, okay? In your exam, they'll also ask you whether it is going to be real or virtual, and you have to explain why. If the image is real, guys, if the image is real, usually it can be projected onto a screen. And like for example, this thing here, this is the image, right? The screen is the one that allows the light to meet in the middle one, right? So if the light meet here, then the image will be sharp. If let's say I put my screen here instead, right? Because the lights meet at different edges, it's going to be blurry one, guys. This is a perfect example of how the lights should be. The lights are actually going to intersect on the screen and produce a sharp image, okay? Anything that can be projected onto a screen for sure is considered real. Anything that is formed by virtual light and cannot be projected on the screen is for sure virtual, guys. So in the exam, they'll ask you something like this, they'll say something like, Okay, guys, this image is either going to be real or virtual. Explain your answer. Why? Why is it real or virtual? It is real because it can be projected onto a screen, or it is virtual because it cannot be projected on a screen. A very standard question with a very, very standard answer, guys. What's the other one? Can and cannot on the screen. Yeah, can be projected 的话，就好像这个 then it is considered to be real. Cannot be projected. 这个是没有可能放一个 screen 在这边 project 的嘛，对吗？ Because my eye is here, right? So this one for sure is going to be virtual one. Yeah. As soon as they are developed by these virtual lights here, can you see these virtual lights here? Then it's considered to be virtual already. Real images are for sure is solid lines all this while all this way to produce them. What green arrow? You mean this eye?
Where's your eye already?
Like see that eye. Your eye will be somewhere around here. It doesn't really matter because it will be projected onto the screen.
Only magnifying glass is virtual.
Yeah, most of the time in your exam, only magnifying glass is virtual.
Everything else real.
Yeah, everything else will be real. But yet again, like I emphasize, you'll know better when you actually attempt the past year question. Because this one here is smaller than this one here. I mean, this drawing doesn't seem like it lah. I'm just giving you an example only, but in the real exams, right? In the real exam, it will give you very significantly smaller or larger. Like for example, you see this one, the object is so big, right? This image is so small, right? Then it's diminished. If this object and image is the same size, they'll write the same size. If they say that this object is small and this image is big, right? Then it'll be magnified. It depends on the question also on, and you are actually, in some cases, you're supposed to measure how tall is the image and the object to find out whether it is magnified or diminished. What? Yeah, this F is basically, okay, since we're on this question here, right? This F here, it stands for, it stands for focal point. Focal point by definition, guys, is the point where all light rays converge. By definition, I repeat, focal point is a point where all light rays converge. They actually ask this in your exam sometimes as well, guys. Converge means to say the light are both coming in.
But then the F is separate light silence.
Oh, it's just a definition. It's just a definition. A lot of scenarios, especially these lens scenarios, the light actually don't even converge at the focal point here. That's why a lot of students, they have a confusion and they can't understand this. By real definition, guys, if let's say the image and object is placed at the principal axis, right, the focal point is supposed to look something like this. But in your exam, they like to ask you guys to draw something like this. Magnified 是它的 definition objects 从小变大就是 magnified 了呀，小 upright 就是说两个 arrow 都是指上去的 ，inverted 的话一个指上一个指下的，你看到吗？ Okay, everyone, please, you need to know this. It's like super. Now I know why you guys are hesitating to do the question. Is it you don't even know?
Yes.
Oh my God. Oh my God. Wow, this is a.
I can't find the right Indian.
This is.
I need to come back to
101. Oh my God. Hey. Everyone, I can only say start doing your passive papers, guys. It's if you cannot do, then you better start doing some topical questions. Yeah. Okay, guys, any other questions from this part here before I throw you guys into that homework that you were supposed to do from last week? I don't know. I don't know. 给我一个机会，我还没有看那个 question. Alright, guys, if you have no other questions, please start attempting the questions. I'll give you, how long do you need for this one? Speed, diffraction, I'll give you exactly 7 minutes, guys, to attempt this question. Then we'll do it together. Yeah, let me see a calculation. I don't know. Let me show. Canvas, glass, air at an angle of 0.62. The angle of refracting glass is 36. Amazing. Yeah. Oh, of course, you're not going to answer it to this amount. Yes, very good, Vicky. You have finally understood the three bigger rule. Hey guys, and I need to emphasize this again because I still see a lot of you guys doing that. Your exam will only allow 3 significant figures, guys. If you lose marks from that, then it's GG.
If the answer given in standard form, yeah,
How much?
you put 2.0 times.
Yep, you can.
And here you read first question. First question. With the kind of and then you start into
Yep, you're going to need the refractive index formulas in this question here, guys. You have 4 more minutes to attempt the question. Everyone. For those who are stuck, please do not remain silent. You may ask your friend, you may ask me. A discussion among your friends is always good for not only the guy who knows how to do it, but also the guy who doesn't know how to do it. It's considered like an active learning scenario, guys. It's definitely better than staring at your paper, I can tell you that. You want to? You know? 你哋邊個契弟有冇帶calculator嚟？你講係邊個定？呢個契弟嚟啊？你又係一個啊？Calculator 在 physics 和 MS class 可以不帶的咩？Wow, 5 of my students are not here today. Who's missing? Ryan, Marcus, Trishan, Abigail. Nova is not here also. Yeah. Oh, yeah, it's minimized. So you do half of the value.
How is glass fibers used in communications?
Why this speed faster than the speed of light one? For example, something is wrong somewhere, right? Your refractive index, how can this bigger number divide by a smaller number? Get an even smaller number than 1. If I'm dividing 3 divided by 2 and you get 0.7 something. It doesn't make sense, does it? And also, oh, sorry, optic fiber. It's supposed to be optic fiber. Right. I use telecommunication. Optic fiber, technology, optic fiber is the one that transmit data through light messages. That's the reason why. That's the reason why it's so fast right now, right? The speed of internet. I'll write something down. I'll give you guys 2 minutes to attempt it, then I'll write something down for you. Mm. Right? You're supposed to end up with 2 times 10 to the power of 8 meters per second. Not 4 for sure. Yeah. 2 times 10 to the power of 8 meters per second. You're supposed to end up somewhere there. Optic fiber. Optical fiber communication one
Generally 好的 我的答错了，老师，我答案是
2 times 10 to the power of 8.
1997没当时我就
Left and right. Okay, guys, for those who are uncertain how to do this question, let's do it together. Hey, listen up for those who do not know. So the first information expected is that this is the incident angle, right? And this is the refracted angle. Okay, then this is the speed of light. And they're asking you to find the speed of light in the glass, which is the medium in this case, which is V, right? So from here, you know that N will be equals to sine I over sine R. And N is equals to C over V, right? Since this is N and this is N, I can say for a fact that sine I over sine R is going to be straight away equals to C over V, right? Right, then from here it's just a substitution of numbers only. Sine 62 divided by sine 36 is equals to 3 times 10 to the power of 8 divided by your V.
1.54
Which, huh?
V is 1.54. Yeah.
It'll be 1.999 times 10 to the power of 8, which is essentially 2 times 10 to the power of 8 meters per second, guys. For those who are still having a problem with the calculator, please make sure you use more brackets, because it's a lot of times your calculator will not do it according to what you want it to do. So bracket it and we definitely know what to do. Okay, then moving on, describe how glass fibers are used in communication technology. This is for sure 100% optic fibers, right? For anyone don't know what optic fibers are, optic fibers are the ones that connect to your modem to the World Wide Web, guys. And the reason why the speed is so fast is because they're using total internal reflection inside to pass on data with the speed of light, guys.
Oh, the yellow color.
No, it's the red color one.
No, mine's yellow color.
What?
Yeah, this one, okay, yellow color.
No, it's
Is
not.
it the one where you?
I don't think you.
Got.
That one is endoscope lah, bro.
the same type of-
Yeah, it'll be the same concept. It will be the same technology and concept, but yeah, it is. Okay, so if you're supposed to explain this in 3 marks, what are you actually expected to say? Most likely, the first statement is going to be optic fiber, or you get the first mark already. Then you're supposed to explain how optic fibers work, which is most likely the lights will go through total internal reflections, sending data through the speed of light or something along the lines, right? Let's see what the mark scheme says. Yeah, it'll be something along the lines. It'll be optic fiber for sure, right? And it sends information through total internal reflection, something along these lines, right? Doesn't really matter how you construct it, but as long as you construct it, it's fine. If I were to construct it, it will be something like optical fibers use total internal reflection of light to send data. Total internal reflection of light to send data to the World Wide Web lah. That's how you construct it lah. Optical fiber 1 mark, total internal reflection 1 mark, and then sending messages another mark or information. Yeah, super standardized answer. Like you'll notice in a lot of your physics questions, most of the answers are quite standardized as well already. So it's just a matter of reading the past scheme. Throughout the World Wide Web lah. I don't know. 这个是第几题？第3题啊。49。Yeah, good. Okay, everyone. Done? If you're done, then let's move on to this next question here. Hey guys, in a real exam, of course, this thing is definitely going to be more scaled correctly, right? But for the sake of this exercise, let's assume that it's going to be half of everything, guys. If it says 2 cm, you make it 1 cm, here is 1 cm, and here is 1.5 cm as well. Okay, if you do this, just the construction of this diagram will look something like this way. Wait, 你还是很累了哎，这么我一直讲话，有人在讲话了，不要讲话可以了吗 ？Oh my god, man！ 我一直讲，一直有人在讲，很累，你知道吗？这样子。Okay, wait. So from here, what you're supposed to do is you're actually supposed to draw the object first, right? Your object is 2 cm high and place 2 cm to the left of the lens. So you're most likely going to measure 2 cm, which in this case here, it's going to be 1 because it's scaled down already, right? Then you're supposed to make it high at 1 cm only, guys, right? Then after that, they say that the focal length is 3 cm, which in this case here, you're going to make it like 1.5 cm away, right? And you write this as your focal point. And straight away off the bat, guys, when you draw this, right, where is the object located right now? It's located in between the focal point and the optical center, which straight away in your mind, guys, you must know that this is going to be a what? It's supposed to be a magnifying glass. If it's a magnifying glass, you know for a fact roughly, right? This is where your image object will be. Your light rays will look something like this, and you're going to dot something like this, right? Straight away, you should have this in your head. Then when you draw the outcome, it will be much easier to understand, guys. For sure, already, ma. What? Ricky, well done, you keep asking the questions that I say. I know for a fact it's a magnifying glass because it's placed in between the focal point and the optical center.
Huh?
What do you mean? Ricky, everyone shut up and pay attention. I'll say this one last time. I don't want to say this again. If the exam, they give you a focal point and optical center and the object is placed in the middle, for sure, I know for a fact that this question is going to be a magnifying glass, for sure, 100%. And if you know that it's going to be a magnifying glass, you know roughly it's going to diverge upwards already, right? And I know it's going to be magnified, upright, and virtual. Well, these are the 3 things that straight away should be in your mind. Very, very, very important, guys. It's very, very important. Like a lot of past years always like to ask magnifying glass. Yeah, 1 cm only. Follow everything divided by 2. Yes, it's supposed to be scaled.
So for convex lens, the object is beyond the focal point.
What? Say that again.
For convex
X,
lens,
which is this one.
No,
You think this is a concave, is it?
no,
Then it must be a convex, ah.
not magnifying one, the real image.
Okay,
The one is the object is not here and the control and then. Okay.
no, it depends on the structure of the question.
Okay. And then,
Is that 1 cm?
no, I extended it.
Is that 2 cm then?
Yeah.
Okay, show me.
You draw your head.
Yeah. Uh-huh. Yeah, yeah. Yeah.
Oh.
我自己
You
这
keep laughing at me.
说这话，这张你看这里哎，这是
No, one here is tall and middle here. Yeah.
这里说的公正。
No,
哦，
good point.
Yeah.
日国公认的呀，呀，我这边要陪我有不快啊。
For the fake line. When you start the drawing.
这种按哦，这个是一点，这个 C， 或者是 C 的 C 什么？
哦，你在那个方面靠谱点，工作了，我们是在别人啊，
不讲他把这个方，这个方法拍，这个是不可能会凸显拍嘛，不知道他在哪里和凸显某位什么的，这是在嘛，对吗？就凸显为比如是1 点，right， 这个然后我考一个线。 这个是红的，这种来的。然后现在讲到火锅花用这边可以知道来这边一点时间，这边可以知道来这边的。哇，这是 C 在红，这个讲到 the middle of the band。
这里是这里跟这里
No，
包括这里
一个
这里
呀，你看，最小的这个，
这里可以不一样。
Yeah. Okay. Wow. I'm surprised. Okay.
Yeah.
Reflection on reflection.
Yeah.
I mean, yeah, you should not. But there's always a way to cheat. To find even if in reflection or reflection, but
That's when I will.
it is reflection, right? It's all right. Where would it?
确定有一些，那一些你好，
This is what the other thing now. If this object is the image of the right now. Wow.
Wow.
Looks a bit parallel or this one. It's definitely not. So, focal point 这个 focal point 不一样的，这个是1.5点，这个应该是1.5点嘛，对不对？
年年，
哎，应该出到对。有个点，没有人不一样的，
多年知道，
我连着不干活。
原来
然后这边说，
可以。
Okay. That's not how it goes, Natalie. Hey, use pencil, please. Not too hard, so. Yeah, looks correct.
Then 要美国水平。
It's okay. Just keep it like this. Okay. Wow, I'm glad everyone is just learning how to draw this.
It's all for the
眼睛为了
draw an arrow 上去 draw an arrow 上去就在这里
If you give us the distance of image from lens, it's like
是啊，我这也是到了。
你是跟那个2边，然后3边，然后过去走。
你让谁呀？
搞上来，搞上来，然后拍你要，
然后你包括说很多他们
你看，知道你要做什么吗？现在这里凸显拍回去，我往前，这个也会凸显 away， 这边 1 cm away is very objective and you be high of 1 cm below。啊，讲这个比以前嘛，which is 1.5，你现在画 1.5，1.5。就是他们也在画，画这边。啊，如果那个这个地方这个的。
Okay, guys, I'm glad most of you guys were able to draw it, but for those who do not know how to draw it, pay attention, everyone. I'm going to draw it as nice as I can, okay? So this object is 2 cm high, and 2 cm to the left, right? I measure here 2 cm, which I told you guys to do 1 cm instead, right? Because of the scaling of the printed material. This is where your object will be placed, and it will be placed 1 cm tall here, right? Then after that, you're supposed to use a converging lens. You measure 3 cm, which in your drawing, you're going to be 1.5 cm. This is the focal point, and you measure here to here another 1.5 cm. This is the focal point as well, right? So after that, you're supposed to draw a straight line, cut through the focal point, cut through the optical center, and then after that, you just draw dot, 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 dot. And this is where your image will be. Okay, your image for sure is magnified, it's upright, and for sure virtual. For sure, all these 3 characteristics.
Monochromatic is only one visible color.
One wavelength to be exact. Okay, guys, anyone online having difficulty drawing this? This is the lens art at all. Okay,
the 2 lines intersect where
yeah, wherever the 2 lines intersect, that will be where the image is formed. Okay.
Then
Yeah, 对了 ，draw 你的 image 上去 ，draw 你的 image 上去 ，you're supposed to have an arrow 啊，这个 arrow 这边折上去。Okay, everyone, I think everyone is okay right now. Then after that, measure the distance, and the height distance of the image to the lens is here to here, guys. It's here to here for the distance of the image to the lens, and then the height of the image is essentially here to here, guys. This is the height, this is the distance. Okay, do it whatever it is, copy it down, measure it or whatever, and then just put these numbers in. And it will be free. 5 marks, guys. Free 5 marks.
If you make my
Huh? Paper 4. Yeah, okay, whatever it is. And then after that, you see this one here, if 1 more free mark, they ask you to state and explain whether image is virtual or real. Okay, real or virtual? For sure, virtual. Why? Yes, for sure. And everyone see this mark scheme here? It's essentially free marks. Shit, where image virtual, why cannot be seen on the screen? For sure, standard answer, standard question. 2A, what? 6 what?
Yeah, the radar.
You're crazy, man, dude. How can this be 6 cm? We just shrunk it down to 1.6.
Oh, crazy.
No, what the hell? Okay, yeah, then if that logic, then it will be somewhere around 3. Milk range. Yeah. It'll be 6, 6. Will you guys get 3, 3? Do you guys get 3, 3?
I get 2 for 1.
5.6. Wow, a bit far, yours. Okay, I have one issue I want to mention to everyone as well, guys. Everyone pay attention. Hello, everyone, pay attention. Hello. Leanne, please pay attention. It's for your sake, not for mine. It's for you. Okay, let me tell you why some of you guys have a different answer, even though the answer is around 6 cm, guys. Some of you guys could have either drawn your arrow a bit slanted like this or slanted like this. You're supposed to make sure that it's perpendicular against this line here. Some of you guys may have drew an arrow that goes something like this or something like this. Of course, not so夸张, right? Obviously, no one has autism here, right? But it should be directly perpendicular like this, guys. It's supposed to be like, I mean, guys, come on. You drew it like this, or like this. It's autism going Okay, but anyways, you're supposed to be perpendicular, guys. It's supposed to be perpendicular, guys. Very important. No, you could use that for 90 degrees, or you could just straight away use this to measure. You know, like how you place the bottom line here and then the line here. Yeah. Okay. Okay, yeah. Okay, guys, any other questions from this part here? Anyone still cannot do this, please let me know. Very, very important. Okay. If no, then please attempt question number 3, guys. Draw question number 3 out, guys. It's very important that you draw it out right now. Okay, everyone start doing it. What's your question? Okay, anyone having the perpendicular issue problem? Let me teach you how to do it. Anyone to learn how to draw the perpendicular line, come here and draw it. Learn. For everyone, come in. For those who do not know, come in. I'll teach you guys one time. We know the perpendicular line. Everyone, come in. Okay. Listen up. You see this line here, right? So you move it exactly on the line, right? You make sure that this line is aligned with this line and draw the line up. For sure, perpendicular. For sure, this one will be. If you use this as a reference for this, right? For sure, it will be perpendicular. Then after once you have this, right? You do the same thing also. You use right now you have this line already, right? What you do is you make sure that this line and this line are aligned, right? Like this. You draw something like this, for sure will be perpendicular as well. But right there from there you can. Oh, yeah. Now you see. Draw, faster draw.
What's wavelength you read?
You tell me.
Yeah.
Oh my god, meters. Hertz. Frequency is hertz.
So what do you do for wavelength? Anything that needs to measure length is in meters. Anything. But that looks a bit too small. Is that correct?
V or
You know what? No.
right?
Yeah.
The speed and then that's
Maybe that. How do you use this speed?
what is not in light? I mean the question's okay.
Natalie.
什么新标？新标啊！我肯定我得顶。
像给人打这样彩色。
CD is what?
That doesn't look right, by the way. How can the image be here when the object is here? It's like you stand in front of the mirror, right? And you are standing there beside you with your image.
Oh.
You know?
You see your Is it the same like this?
This one looks more correct. This one looks very. It's me. This is reflection. Reflection. Yeah, this is correct. But that's not where you find it.
Right, your head.
Yeah, you do. Yeah, you do. Yes, you do. Are you serious? Yeah, then after you find it, then after how you find it, me. Second one.
Oh,
Yeah, very good. You think how to come on? We're supposed to extend this one back. Yes.
I don't know how they say.
In the level. It is virtual life. Sorry.
Yes, sir.就玩嘛，自己这些未必玩的，是啊，你自己玩，反正你纯给，或者你对我是呀，
对不对？我觉得一个是推荐你我们家我去了啦，那个男主角很好的，我们也肯定
在好多这个，你知道他有个
你看过没有？
教你没有接你，
OK，那个是一个可以对吧？
原来不是吧？
The football line. That's football line. Football line. But you know,
这个你是谁要看推导，不然讲看东西嘛。
Okay, everyone, for those who are still very confused, sadly the time is now, so I have to show you how to draw it, guys. This one, everyone is a bit confused, guys. Hey, I want to ask you guys, hey, everyone look here, wait, everyone, you, like I said, it's very easy for me to do it, but when you do it yourself, it's a totally different story. Let me ask you guys, some of you guys, right, I see, the image is somewhere here. Do you know that if, let's say, right, the image is here, it's like literally standing in front of the mirror, then your image is on the left of you. That's, that's how it is, you know? So impossible, right? For sure, it's, oh, Xian, you're here. So it's definitely not this one, right? For sure, 100% ma. And what did I say to you? If you stand, just imagine yourself standing in front of the mirror, guys. If you stand in front of the mirror, where is your image? Right in front of you, of the mirror, right? If let's say this is the object and this is the reflective surface, the image should be right opposite the object, right? Which should be somewhere around here, right, guys? It should be somewhere around here, right? So from here, if let's say you want to cheat, which I have recommended all of you guys start doing by now, you're supposed, you know how to cheat or not? You're supposed to measure this perpendicularly down. How long is this? Let's say 5 cm. You're going to use a ruler perpendicularly down 5 cm and you straight away find the image here. With this, then it's easier to do, right? Because with this, you know for a fact that the normals will be somewhere around here, right? Okay, everyone, please look at this. Hey, don't copy first, right? Seriously, you don't even know what's going on. Copying won't give you shit. Everyone look here, okay? If you get this image here already, right, you can start drawing a virtual light, right? Because I know for a fact that the reflected rays are going to be the ones that are going to virtual back downwards, right? Then from here, with this line already, you can draw straight away like this, right? With this step out, you don't even need to bother measuring how much this is, how much this is, how much this is, and how much this is, because straight away it's automatically correct already. You guys got, I mean, this is very important. That's why I keep saying you need to have the general image of how the virtual, the magnified, sorry, the reflected image is supposed to be. It is exactly what I drew from the start of the class, right? Just that I do it backwards, this one, because I know for a fact that the image is going to be somewhere around here already, man. And some of you guys lagi thorough. Some of you guys see drawing down like this. Wait, hello, this is reflection, man. Hello, reflection, man. Bro. B is definitely not the same thing. That one is refraction. Read the question. Oh my God, guys, you understand what I'm talking about? It's very important that you have the image in your head. Then you can backwards, you can reverse engineer and draw your answer out.
Is it like this?
Yeah lah, then you dot it back. I'm not going to explain this already. Yeah, that's correct already. Very good. Yeah, hey, but hey, let me tell you, guys, in your exam, you better make sure you rub this away. You don't rub this away, they'll know that you cheated, guys. This line here, for sure, they know that you cheated. No, you're not supposed to include that. This is, I tell you, you're cheating. You're supposed to rub away this line here, guys. This line here cannot be here, guys, because you're cheating. Yeah, the answer. When you write on the start, you could have started. No, this is for testing purposes. This is beta. We're in the beta phase. They will not care, guys. They will not care. 看他心情哦, I would say. And then finally, this last. Water is denser, yeah? Huh? 这个是 reflection 了，就好像你 take a piss on the floor 然后看到自己一样子，那时候 B is refraction, yeah, this one will be refraction. Yeah, so it's going to bend away from the normal law, right? So it's going to bend like this, then it will bend more like this, because, hey guys, your second light ray should bend more because you ultimately want it to triangulate back to somewhere to locate the image, right? So it's very important, guys, that you draw it nicely for yourself. That's why I keep saying you need to have the image in your head, then you know how to reverse engineer and draw it already. Draw the normal, draw this one, bend a little bit. Oh, yeah, shit. It didn't bend it as I hoped it to, but you bend it a little bit, you bend this one more, then you can triangulate it back somewhere here.
Inside the water.
Yeah, for sure, the image is going to be inside the water. You could argue it's the same thing.
I didn't bring paper, I didn't bring fucking ruler.
Calculator 又没有带来 ruler 又没有带来
不是。
累啊 very tired bro, very tired already. Okay guys, anyone having problems with the drawing, please let me know now, because you can guarantee one question is going to ask you to draw. It's either going to be this reflection, refraction, or the lens one. Yeah, good. Draw a normal. Normals. It looks a bit too parallel, this one. Open one bend less, then this one you can bend more. You get what I mean? You have two lines that look almost parallel already. One bend less, one bend more, then you can triangulate it back down, because you ultimately want to triangulate it downwards. You get what I mean? Yeah, endoscope for medical use one.
We test the job.
What?
Shut up
What great.
Like now someone different job.
To view internal organs, for keyhole surgery. Gong. 有这两个人翻有时候你看他们为止，然后
一个长长的东西。哦，它这个插头那个。你那有一个是这里来，有一个是从后面拿。它是开门来的，风格出来了，就是。因为你的
Okay, guys. Okay, anyways, guys, this is all the time we have today already. I want you all to go back home and attend this paper. I have sent the mark scheme to the group chat already since last week. Please check your answers from here. What was your question? Oh, no. Diagrams one? Okay, diagram you don't need to ask me. Oh, this one is it. The endoscope, you just need to draw like the Pac-Man one. You draw the Pac-Man, then after that, wait, let me draw first. And you draw this monitor, then you draw like the endoscope inside with the camera inside. Okay, then you label everything. This is the endoscope, this is the monitor, this is the human patient, and this is the camera inside. Statement to now what other internal organ or like those stick user. Yeah, camera, patient, endoscope, which is made of optical fibers. This one is optical fiber. You can just draw the optical fiber, but I usually draw yeah, 做完全部。Okay. Very good. What was your answer in the end? Very good, very good. And everyone, please go back home, right? And attempt this question. This specific question, and let me know your answer by next week. Okay, guys. That'll be it for today. Sorry? What D? What D? This is not D, bro. This is a monitor. Yeah, I can. Monitor, the one that sees the inside.
Yeah.
Endoscope, but it's actually made of optical fiber. You can say that this is optical fiber also. Okay, guys. Yeah, anyone online got any questions or not? Answer. It's in the group chat. Go check it later on. Go check it out. It's the same one. The answers are always going to be optical fiber, endoscope, view internal organs for keyhole surgeries. All these same answers all the time. Keyhole surgery for, yes, you cut a small little hole and then you do the surgery there. That's called keyhole surgery. Now for appendix, they do keyhole surgery. Last time they had to cut the right side on, right?
我哪里知道？
Keyhole surgery. Yes, the key, then the hole. Just end lah. Just end lah. That keyhole is where the surgeons see inside, like, oh, this cut I need to cut. They'll cut a little small hole because of an advancement of technology. They'll cut it out and they'll remove it and they'll sew you back already. You don't have to cut a big hole anymore because of the advancement of technology now.
你过过你的伤口，一跟我
Yeah.
讲的话，一波啦。
Endoscope and keyhole surgery.
Endoscopes are used for keyhole surgeries to view internal organs. Anything along the lines, huh? Yeah. It's a very standard question, actually, with a very standard answer as well.
对这个
Okay, guys, anyone, any questions online or not? If you have no questions, that's it already, guys. I'll see you guys next week.
那个什么的，那这里是吧？是一个
Single wavelength. Single wavelength. Huh? I would definitely highly recommend drawing the diagram. It is very, you don't, but you will highly be recommended to.
One thing that we can.